Welcome. Today we're going to learn about limit, the basics. We're going to start with a graphical approach of limit. So in item 1, you're being asked to find the limit as x approaches 4 of a particular function. In this case, our function is x minus 4 over x squared minus 16. And you can see that in item 2. So what does it mean when I ask for the limit? Well, what we're really saying is, as you approach, as the x value approaches 4 in this particular function, what does the y value approach, or the f of x? And that's what we're really looking at. So here's a graphical approach. We have a graph. If you go to item 3, around that location, that's where x is equal to 4. You can see I've got two little people, and they are think of them as standing on top of the graph. Okay, so that could be you. You're standing on the graph on either side of the graph. That's why I have two people on both sides. And you're literally walking towards the value on your graph where x is 4. So whether you're on the left or the right, you're approaching 4. And the question is, what, as x is approaching 4, what are those y values approaching? And if you follow the dashed line across to the y-axis to see where you are in terms of y, item 5 shows you that the y value is 0.125. Okay, we're pretty close to that. So in this case, the answer is the limit as you're approaching 4 is 0.125. Now, at 4 itself, which is at item 3, if you notice there's a circle, that's because our function is actually undefined. If you replace x with 4, you're going to get 0 in the denominator. So it doesn't matter if that's the case. What we're really looking for is what it approaches as we get close to 4. Now we're going to look at a numerical approach. Same problem, but a numerical approach. So we've created a table which you can do with your graphing calculator, and you can plug in your, if you keep x as an independent variable, you can plug in your own x values in ask mode on the graphing calculator, and then find out what the corresponding f of x or y values are. So again, top row, the x values are approaching 4 from both the left and the right, just like our person was approaching from the left and the right. So we have 3.5, 3.9, 3.99. The values have to be very close for this to make sense. On the right side, 4.1, 4.01. Okay, and you can even get closer than that. Then the question is, because that's what we're asking, what is the limit? We want to know what the y values are. So if you look at the y values, they're 0.133, 0.125, 0.125. And the same from the right, 0.123, 0.125. So as your x values get very close to 4, as they are, 4 is in 2, the y values are approaching 0.125. It doesn't matter that it's undefined at 4. It's what they're getting close to as we get close to 4. Now we're going to do an analytical approach as our last approach. Same problem. What is the limit as x approaches 4? So this is more algebraic. So in item 2, we're going to first do what we call direct substitution. We're going to replace the x with 4. And unfortunately, in this case, we have something that's undefined, zeros in the denominator. So we have to take a different tact. And so if you move to item 3, fortunately in this problem, we were able to factor the denominator using difference of squares. We canceled the x minus 4, and now we have 1 over x plus 4. Now we try direct substitution again. Replace x with 4, we get 1/8, and guess what? That's 0.125. Sound familiar? So that is our limit. And that's limit the basics. Now go practice, practice, and practice some more.